This project focuses on the application of Civil 3D in heavy design and alignment planning. Civil 3D allows designers to work with terrain modeling, alignment geometry, profiles, and corridor design in a dynamic and coordinated environment. It is widely used for infrastructure works, including roads, stormwater management, and land development. For our case study, we focus area is Kota Samarahan in the state of Sarawak historically. The region functioned mainly as satellite township of Kuching, but over time it became a educational and residential hub with institutions such as UNMAS and UITM. As development increases, so did population mobility and daily community activities between Samaraga and Kuching. These changes created significant demand for efficiency-heavy design and traffic management. Therefore, Civil 3D is not just used as an academic exercise, but as a way to explore heavy planning, improve design clarity, and assess the engineering considerations required for the future expansion of Sarawak's transportation network. In Sarawak, especially in Kota Samarahan, there are several transport problems that affect daily travel and road performance. The first problem is road sediment. Many areas have peat and soft soil, which makes the road sink or become uneven after some time. When the road becomes bumpy, it is uncomfortable for drivers and can be dangerous during rain or at higher speeds. The second problem is traffic junction. As Samarahan develops into a residential and education hub, more people travel daily to and from Cochin. This causes long queues during peak hours, especially at roundabouts and main junctions. The mixed traffic of cars, motorcycles, and other vehicles also makes traffic less predictable. The third problem is drainage. During the monsoon season, rainwater can collect on the road because of the drainage system cannot clear water quickly. When water sits at the road, it reduces frictions and increases the chance of accident, especially for motorcycles. The last problem is the environment. Many paved areas absorb heat, making the surrounding hotter. Over time, this extra heat can damage the road surface faster and increase maintenance needs. These problems show as the road design and transport planning in Sarawak still need improvement to support future growth.
The next, I will talk about solution of transportation problem in Sarawak. This is the key element of solution lah. First of all, is road settlement of soil stability. We can apply soil stabilization technique, geotechnique, lime, cement treatment. Next, design road foundation based on local soil condition. Secondly, is traffic classification, mixed vehicle speed, which is implement traffic management and signal optimization, provide separate lane for heavy vehicle and motorcycle. For the drainage issue, we can upgrade roadside drainage system and culvert, confirm routine drain cleaning and maintaining. Next, environment impact, urban heat and pavement egging. We use heat resistant or modify asphalt material and introduce green buffer and roadside tree. That's all.
Statistics shows that accidents that occur on the Kota Samarahan region is quite high, with 18,578 casualties in 2012. Most of the roads in Kota Samarahan contains organic material, adding challenge to the road construction. From the table attached, you can see that road accidents is rising significantly from 2006 to 2012.
Today, I will talk about data point of surveyor. This step showed the creation of an existing ground surface using survey data from KS Sarawak. That KS Sarawak is our project lah. We chose that place. The point displayed in the drawing represent field survey point collected by KS Sarawak. And lastly, at this stage, the surface of displacement mainly as survey points to allow correction point, distribution, and possible survey error. I will talk about the existing ground surface. Okay, as we see in this picture, this is the existing ground surface for the point of the map in Kota Samarahan, Kota Samarahan, Sarawak. This existing surface represent the nature certain of the project area, including hill, valley, roads, and another ground feeder. If you see in this picture, you see the one that have a lot of land is the higher lah, the hill. One with the not more frequent line is low ground. That's all. Thank you.
Okay, this page shows the surface analysis of the project area in Kota Samarahan using Civil 3D. The surface was analyzed to understand the existing ground condition before designing the highway. Okay, we see at the first picture, which is the blue one, the elevation analysis is displayed using color bands. Dark blue areas represent lower elevations, while lighter blue areas indicate higher elevations. From this analysis, we can see the most of the area is relatively low-lying, which is common in Kota Samarahan and closely related to peat soil conditions. Next, we go to the second picture, the red one. Okay, so this is the slope analysis, which shows how steep or flat the terrain is. The area mostly consists of gentle slopes, making it suitable for road alignment, but it still requires careful design due to settlement and drainage issues. This surface analysis is important because it helps engineers determine cut and fill volumes, plan effective drainage, and ensure the road design is safe and economical. Uh, that's all from me. Thank you.
Alignment design in Civil 3D software allow us to define the location of the target intended by establishing the horizontal geometry of the roads. This feature also can generate the profiles for the existing and proposed ground, other than creating corridors and cross-sections.
For this slide, I will explain about curve and spiral. Before we make our curve and spiral, we need to identify speed and radius that's suitable in our road. So, how to identify speed and radius? First step, we need to identify our area, either rural or urban. For this case, we choose urban because in the geotechnical shown urban location. And the second step, we need to choose the design standard for this project. So we choose U4. And the third step, we need to state our area type. For this location, we choose type 2, which is intermediate between detailed problem on LA and very constants. And step 4, we need to check the and choose our design speed in the table above. So it's shown 16 kilometer per hour for design speed, and the last step, we need to identify the radius in the table for 7A with the speed value that we already identify. It's shown we need to choose 135 radius. So for all the value, we can design our curve and spiral. So for this slide, it show the output of existing profile view. This profile view show the existing ground profile. From the table, we can see the existing ground profile band is referred to elevations. The horizontal geometry band is also curve. It show the curve and tangent above. The proposed profile band is our design profile.
Next is super elevation. Super elevation is a road cross-section used on curves, where the pavement is bound to counteract centrifugal force and keep vehicles stable. In our Civil 3D model, we designed the curve using a 60 km per hour design speed with a 135 meter radius, and the radius determines the required super elevation rate. In the strict section, the road remains in a normal crawling condition. With proper super elevation, vehicles stay in line, terrain is smoother and more comfortable, draining water better, and overall safety improves at the design speed.
So for this result, it show the output of final result. The photo show the final result of the profile view. Our proposed road is the blue line and the existing ground profile is the red line. area between the existing which is red and proposed which is blue line represent cut off field volumes. From the photo in the first section, we can see it show that we need to fill the volumes, and the second and the last section it show that we need to cut and fill a little bit volumes.
Highway development in Kota Samarahan is affected by soft pit soil, low-lying terrain, heavy traffic, and poor drainage. Civil 3D analysis shows height fill requirements that increase settlement and pavement deformation risk. Therefore, integrated soil stabilization, drainage, and safe geometric design are essential for long-term road performance. Thank you.
In conclusion, Civil 3D software helps us to tackle several tasks that requires software skills like acquiring data and mapping purpose. Civil 3D also provides us with efficient solutions to solve issues like highway construction and earthwork estimation.